Hey guys, today we're going to learn how to graph reciprocal functions. So you will need your calculator handy to do that, and I've already filled in the top part of your paper here. So a reciprocal parent function is f of x equals 1 over x. As you can see, the graph is a hyperbola. That's called hyperbola, which means it looks almost like two kind of flattened parabolas. But in this case, we have a vertical asymptote and a horizontal asymptote. Here's your horizontal asymptote at y equals 0, vertical asymptote at x equals 0. And I use the point -1, -1, and 1, 1 kind of as my guide along with my asymptotes. So the domain, x cannot equal 0, range cannot equal 0. And then we've talked about your vertical and horizontal asymptotes. If we were to do a transformation with a reciprocal function, it would be a over x minus h plus k, where h is the horizontal shift, positive moves left, negative moves right, k is the vertical shift, positive moves up, negative moves down. If a is negative, the function is reflected across the x-axis. If the absolute value of a is greater than 1, you have a stretch. If the absolute value of a is between 0 and 1, then you have a compression, both of those of which are vertical. So what we're going to do is write the function here based on the information that's given in our problem. The reciprocal parent function is reflected across the x-axis. That means a will be negative. It is translated 4 to the right and 3 down. Write an equation to represent the new function, and then identify the asymptotes. So our function notation is reflected across the x-axis. Over. Translated 4 right, that means x minus 4, 3 up. So your horizontal asymptote and your vertical asymptote, horizontal is going to be, I'm sorry, that's down. So it should be negative. Horizontal is going to be based on what's here. So that would be y equals -3, and vertical asymptote is what makes the denominator 0, which is x equals 4. The reciprocal parent function is translated, the reciprocal parent function is vertically stretched by a factor of 2 and then translated 7 up and 1 left. Write an equation and then identify the asymptotes. So it's stretched by a power of 2, and it is translated 1 left and 7 up. So your vertical asymptote is x equals -1, and your horizontal asymptote is y is equal to 7. A reciprocal function has a vertical asymptote located at x equals -2 and a horizontal asymptote located at y equals 5. Write an equation that could represent this function. So it has a vertical asymptote at -2. So that means -2 would make that denominator 0. So x plus 2. The horizontal asymptote is located at 5. So we put our plus 5 out to the side. And now we're going to take our calculators and we're going to graph the functions 4 through 9. So we're going to do that first and then go back and identify domain, range, and our asymptotes. So if you will just, the best thing to do is for me to pause the video so that we're not taking video time to graph. So I'm going to pause the video. I'm going to graph 4 through 9. I'm going to come back and we're going to talk about the different parts. Okay, welcome back. Now let's take a look at those graphs. Now, it's hard to see an asymptote sometimes on a graph, but if you can look at the function and you know what the asymptotes are based on the information that we just learned on the prior page, sometimes that makes it easier to start your graph there and fill it in based on your calculator. So we should know that the vertical asymptote is at x equals 0 because that's what makes the denominator 0. And we should know that the horizontal asymptote is y equals -2 because that's the rest of our function. So the domain and range are real simple. It's x cannot equal this number and y cannot equal this number. So taking a look at number 5, our vertical asymptote is going to be x equals -3, and horizontal is y equals 0 because there is no number out to the side. Domain x cannot equal -3, range y cannot equal 0. All right, if you will pause your video, I would like for you to do 6 through 9 real quick. I'm going to fill those in, and then that will be the end of our video for today. So x equals 0 and y equals 1. X cannot equal 0 and y cannot equal 1. X equals 2. y equals -2, x cannot equal 2, y cannot equal -2. And for number 8, x equals -4, y equals -7, x cannot equal -4, y cannot equal -7. And for 9, x equals 5, y equals 3, x cannot equal 5, y cannot equal 3. So graphing reciprocal functions is pretty simple. We're going to be graphing rational functions next, and we have a lot of characteristics, the characteristics that you're used to. So we'll be doing that in our next section. I hope you guys have a great day. Let me know if you have any questions, and I'll talk to you soon.